All right, so today we're doing 6-4 factoring trinomials. The first thing I want you to do, just like we did before, is we always use our X marks the spot, and I want to know what multiplies to 39. We're looking for a product of the top of this X and adds to 16. Okay, Caitlin, what'd you get? 3, positive 3 and 13. Okay, so let's try that. I want you to pause the recording, and I want you to finish doing these the same way. Okay, sorry about that. I didn't give you the... Okay, now pause the... Let's look at these. Number 1, what are you getting? Who did I call in last? Okay, Sebastian, what's number 2, the next one? 4 and negative 3. Okay. I'm recording. Okay, the next one. Let's see. Hannah? Negative 2 and negative 2. Add to negative 4. That's correct. Okay, next 2. Eric?
Negative 2.
What'd you say?
2 and negative 2.
Positive 2, negative 2. Perfect. Okay, they add to 0. Sarah? 12 and negative 2. Good. Okay, and then, yes? No, I'm asking Tatiana.
Negative 3 and 14.
Negative 3, 14, correct. Okay, questions? Let's try some more. Okay, we're doing the same one. This time I want to know what multiplies to 56 and adds to 15. Let's go with Caitlin. 7 and 8, good. Okay, we're doing the same thing. Let's try these. Now pause the recording and finish these up. I'm saying if things get confusing, I want a factor tower. What adds to 44? 1 and 44. 2, 22. 3, no. 4 and 11. Already I see it. Do you guys see it? Does that add or subtract? It's going to be negative 22 and positive 2. Okay. So let's start with number 1. What is the answer? Let's go with Max.
The answer is negative 10 and positive 4.
Positive what? 4. Does that add or subtract to negative 6?
Yeah.
Does it multiply to negative 40? Okay, good. We're good. Next one. Let's go with people I haven't heard from. Michael.
I got negative 15 and negative 6.
Negative 15, negative 6. Agree or disagree? Good. 15 times 6, isn't that 90? Yes. Okay. Because 15 and 6 times 5 is 30. Carry the 3. 30. Carry the 3. It's 6, 7, 8, 9. It's 90. So, Michael, try again. Negative 16, negative 5. That multiplies to positive 80, and that adds to 21. Good. Okay. Double check yourself. Okay, yes.
I got negative 2 and 33.
Negative 2, positive 33. Okay. Next one, Leo.
12 and negative 4.
12, negative 4. They add to 8. Yes. Oh, they add to... Stop. Leo, correct it.
Negative
12 and 4.
Negative 12.
Negative 12, positive 4. Do they add to negative 8? Yes. Do they multiply to negative 48? There it goes. It works. Okay, if you were able to do this, this is the next form of factoring. The biggest thing you can do to hold yourself up is to sit there and do nothing and stare at the sky and think it's going to come. Do a visual. Make your factor tower. You really don't even need to do this slide, because we've done everything we need to do. Remember when we were double distributing, we found that the last two terms added right? And the first term was the product. Okay, well, when we're doing this, remember, isn't that the same thing? There's the sum, right? And there's the product. So all we're going to do is we're going backwards. We're going backwards. And so we are going to do our X marks the spot. And I don't want you to do it like this. Let me erase here. Because I want you to model it the way I'm showing it here. No. Pretend that equal sign is not there. Okay? So, the first thing I want you to do is we are making our parentheses, and we're going to make our little X marks the spot. What goes in the top? 10. What goes on the bottom?
7.
That's our sum. Now, what are the two numbers? 2, positive 2, and positive 5. Now, what's the square root of x squared? X. So x times x makes that x squared. Place it. And then I have a positive 5 and a positive 2. Pretty easy, huh? Oops. I wrote positive 5, positive 5. Positive 5, positive 2. Does that make sense? Okay. Let's keep going. Now, I don't want you to add equal signs, and I don't want you to work horizontally. Got it? I want you to work the way I just did it. Now, you'll notice in my PowerPoint, this is just a factor tower here, right? They're just giving us what's the factors. Okay, you'll see that. All right, so let's do the first one together. Okay, what goes up top, please? 20. And what goes on the bottom? 9. I'm looking for a product and a sum. Okay, what are my two numbers, please, Miriam? 4 and 5. So it becomes 4 and 4. 4 and 5. Sorry, I'm still sick getting over my... Okay, what is the answer, Miriam?
It's x plus 5, and then x plus 4.
Now remember, the product goes up here. The sum goes down here. Go. You try the next one. Next two. Pause the recording. Let's begin. So what goes on top of my X marks the spot, Noelia?
12.
Thank you, Noelia. And what goes on the bottom? Negative 8. And what are my two numbers? What are the two numbers? Noelia? 2 and 6. Which one has to be negative to make it negative? 6, 2, or both? Okay, that works. They add to negative 8 and they multiply. So what's the answer, Noelia?
Equality of y minus 2 and y minus 6.
Good. Okay, number 2. The next one. Let's go with Julia. What goes up top? 12, and on the bottom? And so what are my two problems? Negative 3 and? Good. And so the answer is?
M minus 3 and n minus 4.
Good. Question.
Should you, put the smaller number first?
Doesn't matter. Not at all. Doesn't matter if the smaller number goes first. Okay. So now, did we do that one? Okay, this is no different. They keep saying, well, what happens when C is negative? We're still doing the same thing. Either you do your factor tower to negative 12. We can say 1 and 12, 2 and 6, 3 and 4. And we add and subtract and see which ones. Or we do this. Negative 12, positive 1. So what is it going to multiply or divide to? Eric? What are my two factors?
3 and 4. Negative 4 and 3.
Negative 4, positive 3. So we get what? What's the answer?
X minus 4 times x plus 6.
Good.
Negative 4.
Negative 4. Oh, So does negative 4 and positive 3 add to positive 1? Shh.
Yes.
Really? Negative 4 plus 3 is
Oh,
what?
negative 1.
So what's the answer here? Shh. What's the answer?
Negative 3.
Negative 3, positive 4. So plus 4 minus 3. Okay?
I can math.
Okay. Do you guys still feel okay about this? Okay, I'm gonna go to the more difficult problems now. If you want more practice, you can pause it. Shh. So, when we are factoring, okay, so we have learned, we are now learning trinomial factoring. We've learned all these different kinds of factoring. Now we're just doing general trinomial factoring. Okay, you've got 2 more methods left. I don't know why they said 5 types. There's really 6. Oh, 5, but then there's 6 types because there's factor by grouping. Now, once you learn it all, they're going to start mixing the problems together. Okay, so what's the first step we always do? Look at the chart. GCF. What is the GCF? 3. So I'm going to pull out my GCF of 3. Okay, and then what? Am I left with anything that can be factored? Okay, Sebastian, what am I doing? Make your X marks a spot. What goes up top?
12 and 7 on the bottom.
Okay, and so what are my 2 factors?
4 and 3.
Positive 4, positive 3, and so it's 3 times what?
X plus 4 times X plus 3.
Is that making sense? Make sure you factor till every single factor can't be factored anymore. You have to factor completely. All right, this is what we call a higher order polynomial. So when x squared is not the highest degree, you're probably going to be left with more factoring. So what would I do first?
There's no GCFs.
There's no GCF. This is not a difference of squares. There's a trinomial. So I'm just going straight for my x marks the spot. What multiplies to 4 and adds to negative 5? Now when I'm factoring this, first of all, when I have x to the 4th, what times itself equals x to the 4th? X squared and x squared. Now I'm using the same x marks the spot. What are the numbers here that go in my x marks the spot, Sebastian?
Negative 4 and negative 1.
Negative 4, negative 1. Does that add to negative 5? Does it multiply to positive 4?
Yes.
So I am getting a minus 1 and a minus 4. I just place them there. Now am I done? No. Why?
Because it's a difference of squares.
I've been left with what? 2 sets of difference of squares. So the first is trinomial factoring, right? And then I'm left with my difference of squares. X squared minus 1 factors to what? X minus 1 times x plus 1. And x squared minus 4. Now, every time you get an answer, you have to say to yourself, can this be factored more? Can this? Can this? Can this? And you cannot write these two, x plus 2 times x minus 2. You cannot write that as x minus 2 squared. I had a lot of that. It's not the same thing. So don't write it like that. It has to be written, expanded out like that. Because they're not exactly the same. The sign is different. Does that make sense? Yes.
Can you factor out x minus 1 more?
No, there's no more.
Oh, yeah.
There's no x squared. This is not a perfect square. This is, but this is not. This is not a perfect square. this would be, if anything, but x squared, x is not a perfect square. Yes.
So what would you do if it was x squared plus 1?
Stop. A sum of squares is not factorable. So the question is, when you have when you are factoring and you have a binomial, the only kind of binomial that is factorable, okay, is a difference of squares. That's a perfect square minus a perfect square. A sum of squares is not factorable because no two binomials will ever multiply to equal this. Do you understand? When any other two binomials will either give you a difference of squares or they'll give you a trinomial. Do you understand?
Yes.
It will never give you, there's no way to get that. The sum of squares, we stop. Greg.
As a hypothetical situation, could you just put the square root of x? Because it's the square root of x times the
No.
square root of x.
Nope. Stop. Okay. Now, let's go here. Okay. Now we've got step 1. What are we doing? You should be writing these. Step 1, what are we doing? Greg.
You're factoring out the GMF.
GCF.
Okay, it's monomial factors.
Okay, GMF. Okay, good.
So
And what is it?
y.
Y. And then I'm left with y squared. By the way, y cubed is not a perfect square. So the only way that can be, because a perfect square is a number times itself. Okay, now, again, now look at this. Don't be confused. It's not so hard. Okay. So first I did my GCF, right? Now, even though I have a higher order, even though I have multiple variables, I'm still taking the sum and difference. The sum and the product. Plus 6 goes up here, negative 5. Now, let's finish this. What's the root of y squared? Y and a y. What's the root of, let's just look at the variable of a squared? A and an a, right? I got to place them. Now, what are the two numbers that multiply to 6 but add to negative 5? Sarah? Negative 2, negative 3. Now, where to place those? Do they go in front of the y's or in front of the a's? They have to because the coefficient is in front of the a. So it's minus 3a minus 2a. Does that make sense? Yes. Now, if you multiply it back, I get negative 3ay. And then here, I get a negative 2ay. Doesn't that add up to? Doesn't it add up to this? Stop. Let's do the next one. Shh. Okay. Step 1. Okay, what are we doing? Step 1. How do I do the x to the 4th? Is there a GCF? No. So, x to the 4th is what?
X to the second.
X to the 2nd. Now, what multiplies to negative 12 adds to negative 1? Greg?
Negative 4 and 3.
Okay, so I am doing plus 3 minus 4. Are we done?
No.
Because I am left with a difference of squares that is still factorable. And this factors out to what? Plus 2 times x minus 2. All right, one word about your quizzes. And there's nothing else that I can do. One word about your quizzes. I'm not worried that it wasn't such a positive experience. I really feel like there's a lot of kinks to work out of factoring. It's new. And by the end of the chapter, it usually sticks. Okay? So, tomorrow I'll give you your quizzes back. Is there anybody that needs to make it up?